what's up, everyone? This is Pratik, and today we have François Lachance from Canada, and he works with Sonatest. And I met him at the ASNT conference just a month ago, and I saw this piece of equipment over there. It's called the Sonatest Wave, and it's pretty interesting. I got to play with it for some time, and I wanted to talk to Frachance about the details of this equipment and what's new, and who should be using this equipment.
Thanks, Pratik, for giving me this opportunity to present this new product from Sonatest.
First of all, I just want to know who should be using this. What are the applications where Wave can be used?
Okay, so first of all, Wave is a flaw detector. Okay, so a modern flaw detector, which one of the biggest differentiation factor of this equipment is that we integrated all modern technology inside one flaw detector. So basically, there's a touchscreen. You will have Wi-Fi capability, remote access to this equipment, and the screen that you see on the screen is wireless. You have microphone, you will have basically all the new technology available on the market that you can find on a cell phone. We decided to integrate it into a flaw detector, general purpose ultrasonic inspection, but more specifically weld inspection and manufacturing, and it's more oriented for manufacturing industry related.
Okay, so thickness inspection, shear wave inspection, right? You said it has Wi-Fi.
Yeah.
So how do we use it? What's the benefit of having a Wi-Fi?
But the benefits of having a Wi-Fi could be vast. As for example, in a big manufacturing facility, often the equipment will be removed from the instrument. Okay, so and sometimes the person that will do the reporting will be different than the people that did the inspection. Okay, so it allows you to access everywhere in the facility the equipment, so the screenshot, the information that you save into your device. From one desktop, you can have access to many instruments. Okay, so it's easier to manage from calibrations or software update point of view.
I see. So that makes sense. And then you said it also has a microphone, so you could make like calls and stuff from this device.
No, actually, the microphone is more for audio message that you could record inside the instrument for reporting.
Wow.
Also.
Okay.
So it's not to call your friends.
Okay.
It's for advanced reporting. Yeah.
Can you tell us about? So when I was at the conference, the thing that caught my eye was the interactive scan plan. So yes. Can you, if it's possible for you to demonstrate for like a few seconds what exactly that scan plan is, that would be awesome.
So one of the main challenge for a weld inspector, a UT tech or a UT level 2 tech, is to make the differentiation between real flaw and a geometrical flaw. We came up with the idea to integrate a scan plan inside the instrument. So I have a small T-sample here just to demo a little bit the principle of the feature. So what you see here, it's the geometrical echo here. And what you see here, okay, is the small hole here. So basically, normally the inspector will rely on the measurement that you see on the screen here. It will try to draw the flaw inside the part, and we'll have a brief idea of where the flaw is in the part. So basically, what you can do now is, since you have the interactive scan plan, once you have your echo, okay, then you can position the probe accordingly to the position with a ruler, okay.
Okay, and so you measure it on the piece. And if it says 10 millimeters, you put 10 millimeters on the scan plan on your machine.
Exactly.
Okay.
So it speeds up the step of drawing the flaw localization for the inspector. Moreover, it's helped with the geometrical indication. So what you see on the screen just here on the bevel, it's the indication, and what you see just in the middle of the part here it's the hole inside the part here. Exactly.
Are you able to see the circle that I just drew on the screen?
Yeah, I'm seeing it. Yeah.
So
thanks for that.
this is the defect, right?
Yes, that's the defect.
Okay. And then this one over here you said was the geometry.
Yeah, that's the geometrical reflection.
So then you can adjust these gates. So this whole red line is a gate.
Yeah.
And then you can adjust that to get the readings on the top. That's pretty cool.
Exactly, yeah. 4 different type of part that you can draw. Okay, so you have the flat, the curve, the corner joint as well to mimic a nozzle at the same time. So the TKY, this is a complex shape geometry where conventional sets have sometimes difficulty too. So
right. This is, so I don't know if other instruments have this yet, but when I was inspecting and we didn't have these, we had to actually plot and draw it on a piece of paper using the transparent sheet with all different angles drawn on it. It was a pain. It was pain to draw like these T joints and K joints and try to trace all these things. And we were saying like, I wish we had it, like when we started doing the phased array, we had the S scan, and we wish something like that would exist for conventional UT, you know?
Concept was to go back to the simplicity by allowing the end user to customize the interface of his equipment, okay? And to remove navigation, remove doubt in the inspector, okay? And by removing doubt, you will increase conformity and remove a mistake by the end. So just to illustrate you a little bit like the concept, I pick up airplane -8 procedure inspection. Okay, so it's an inspection in between rivet for in-service damage inspection. Okay. So basically, they try to find track in between rivet of airplane's component. You get into the procedure. They first tell you you need to set your instrument like that. Okay. So if I go here and I launch the application. I'm gonna go here. Basically, if I come back here, I have all the information, so the velocity, the filter, the probe zero, the PRF, the delay, all the information written in this picture, okay, is entered in this menu. Okay. Moreover, the menu here is renamed and is named as the picture name. Okay, so to make sure. So usually when an inspector will get on site, he will read the procedure, he will validate the parameter option, okay, to make sure that everything is accordingly to the procedure. So now you only have one place to look. It's the custom menu created for.
So you're following the procedure as needed. Like you're not having other fluff, other extra stuff that is not needed as per the procedure.
Exactly. So basically, if you keep reading the procedure, you have an ADM notch here on the calibration block. Okay. On the calibration sample, you should have a signal about 80% height, and so when I come back here, basically I have the exact signals that is expected me to have when I'm doing my sensitivity calibration on my calibration block. Okay. So this remove uncertainty from the inspector, okay, make sure that the notch is at the proper place and at the proper height with the proper gain. So if what you can see here is that, moreover, the menu structure has been streamlined to a maximum. So I only kept the parameter that the inspector will need to use during his inspection. Okay. So it's remove parameters that have been changed by mistakes, such as filter and go on and go on. And as well, it's built workflow oriented. Okay, so first you validate your information in the image, then you do your calibration with the reference signal that you have here, and then you inspect. And normally, when you have finished with the 2 other steps, you don't touch anything else, and you just can change your range, and that's the only manipulation you can do. So yeah, the customization feature could go a bit farther as well. When you have a complex part or things like that. So here on the rivet, the cracking is expected to be on this side of the rivet. Okay. So if I come back here, my customization is included on the Rivet at the same time. Okay, so now when you do your inspection, you could see you have the exact part shape that you need to inspect at the same time, which helps you to make the proper call at the proper time. So the globally, this feature is not for everybody. It's mostly for high risk industry, so nuclear, aerospace, and as well big manufacturing industry that really try to improve their quality control process and their conformity and lower their rejection rate. Basically.
Okay, so you can pretty much customize each setup to hide certain functions, hide certain menu items, and show the other ones that are specific to that client, so that the person using it on the field doesn't have to go through a bunch of things that is not needed for that particular project. That is very smart. That is very efficient. It's going to save a lot of time when people are working on multiple projects and you already have the entire machine customized to that project. That is perfect. That makes it so much easier on navigating through the machine. So is this built on Linux?
The specificity of Sonatest, if you compare to all the competition landscape, is that we all our instruments are Linux based. Okay, so
why is that? Why is Linux better than, or like how is it different than using Windows? Because most other manufacturers are using Windows platform, right?
Yeah, but Linux is a language when you have a bit more knob. So basically what it means that you could shut down some component when you don't need them, okay? So it's improved battery life mostly. It will speed up. So it's a more light programming language, okay? So the library that comes with it are lighter. Everything is lighter, okay? So with the same power processing, you will be faster. And also you will consume less battery life. So I will say that's the main advantage of using this.
That sounds really good. And then what's the drawback of having Linux? Is there any drawback of is there a compromise over Windows?
It's a bit longer a bit harder to program. So I will say that's the biggest drawback of this language. It's since you have more knob, it's a bit more complicated to and it could take a bit more time as well.
Got it. That makes sense. So make it harder to make this whole interface, but then it makes it easier for us to use it. I've seen one of these, like when I wanted to use one of these and I started the machine, I was just surprised, like it booted the whole machine in a few seconds. I didn't have to wait. I was expecting to like the circle pop up and wait till it loads, and it just started, and we were like, oh, that's super fast. That's awesome. How much do these weigh? What's the weight of
the weight is 1.7 kilo, so 3 point something pound.
Okay. Yeah. Well, is there anything else we should know about this wave that's creating wave in this industry? Did we miss anything? Because I guess pretty much these were like the highlights for me, at least. I've had experience with a couple other flaw detectors, major ones. And these are the things that I found different in this machine. And that's why I asked you questions related to those. One more question I had is like, are you using Wi-Fi right now from the machine to show me the screen? Yes. Or have you connected using USB?
No. This is, I'm connected through Wi-Fi.
So this is screen, okay. Yeah, so you're casting the screen remotely.
Exactly. So that's why it's lag a little bit on the. Oh, it doesn't really lag, but yeah, it's Wi-Fi connection in between the equipment and my laptop as well.
Your laptop, and it has to be on the same local network.
Yes.
Okay.
So the touchscreen itself really eases the use of the instrument. Moreover, the touchscreen is very well designed. and it's work with the couplet event as well. Okay,
I
so
see.
even if I have a couplet here, I could still drag
Oh wow.
the gate here. Okay, and it keeps working. Okay, so my finger, and it's worked with glove. Okay, so when
Oh,
we
it works
came
with
with the
gloves.
product
Okay.
as well, I don't have glove. I didn't think about it at first, but it was about it was part of the requirement when we decided to go with touchscreen. It was make sure that it's work with couplet, okay, and that it worked with glove. Yeah.
Well, I guess that's all the questions I had about this flaw detector.
Good.
And I would like to say thank you for taking the time to share this. And if anybody is watching this video, wants to know more about this product, do contact. I will leave your. Is it okay if I leave your contact information in the video description?
Uh,
Or yeah.
yes.
Or you can
Yeah.
direct me to the person who people should contact. I
Yeah, I
don't want
think
people bothering you for everything.
I don't want to receive 3,000 email, but I will send you a generic contact point
Okay,
email.
that's perfect. Yeah,
So that's good. Yeah.
that'll work. Well, thanks for spending the time today.
Thank you
And
very much. Thanks to you, Pratik, to give me this opportunity to talk about our new product, and wish you big success in, with your YouTube channels.
thank you.
And I like the stuff that you're doing there. And keep up the good work.
Thank you very much. I appreciate it.
Yeah.
You have a
So
good day.
yeah, you too. Bye bye.
See ya.